Hello everyone, Mr. Hauk here. In today's video, we're going to be exploring solving right triangles using trigonometric functions. By the end of this video lesson, you should be able to solve missing sides of a right triangle using sine, cosine, and tangent, and solve missing angles of a right triangle using sine, cosine, and tangent. Let's get started. So first we're going to talk about Sohcahtoa. So Sohcahtoa, as you might have seen in geometry, is an acronym to help you remember the trigonometric ratios of an angle in a right triangle. So means sine, so the sine of an angle is the opposite leg divided by the hypotenuse. So let's write that down. The sine of an angle theta is the opposite leg divided by the hypotenuse, which is the longest side of the triangle. In our image here to the right, well, keep in mind that when we take the sine of an angle, or when we look at an angle in general, sine, cosine, and tangent are relative to that angle. So if we're going to say the sine of theta, notice that theta is right here and applies to angle A. So opposite of angle A is side A, and the hypotenuse is C, because C is across from the 90-degree angle. So we would say the opposite leg divided by the hypotenuse is A over C. If we wanted to look at the cosine of theta, so the cosine is the adjacent leg divided by the hypotenuse. And adjacent means the leg that is directly attached to the angle. So if we're looking at angle theta, the leg that is attached to angle theta would be leg B, right here. So the cosine of theta would be the adjacent leg B divided by the hypotenuse C. And then next, the tangent of an angle is equal to the opposite leg divided by the adjacent leg. So if we're looking at angle theta, the opposite leg is A and the adjacent leg is B. So we would say A divided by B. So let's put this into practice. Let's use Sohcahtoa to find the indicated side in each triangle. So here in our first problem, notice that the angle that we're given is 32 degrees. And we also know that one side is x and the hypotenuse is 19. And remember, we know the hypotenuse is 19 because the hypotenuse is always directly across from the 90-degree angle. So since we have relative to 32 degrees, we have the opposite leg x and the hypotenuse 19, this indicates to me that we should use the sine of 32 degrees. So the sine of 32 degrees is equal to x, the opposite leg, divided by the hypotenuse 19. To solve for x, we can now multiply both sides by 19. And this will give us that x is equal to 19 times the sine of 32 degrees. And we can use Desmos to go ahead and calculate this. So notice that I have Desmos pulled up. One thing we want to make sure that we do is that since we are working in degrees, if we press on this little wrench, we can choose between radians and degrees. We want to set it to degrees. And now we can just type in 19, and using the functions button, sine of 32. And that's going to tell us that x is approximately 10.1. So I'm going to say approximately 10.1. Okay, let's try another problem. So now notice that we have the angle 50 degrees, and relative to that angle, we know that x would be the adjacent leg. We know that 35 would be the hypotenuse, again, because 35 is directly across from the 90-degree angle. So since we have an adjacent leg and a hypotenuse, that tells us that we should probably be using the cosine. So we would say that the cosine of 50 degrees is equal to x, the adjacent leg, divided by 35. Next, multiplying both sides by 35, we will get that x is equal to 35 times the cosine of 50 degrees. And again, using Desmos, let's go ahead and calculate this. We would say 35 functions cosine 50 degrees, and that'd be approximately 22.5. All right, let's do one more problem here before we move on to the next section of the notes. So now, relative to the 21 degrees that we're given, we have the opposite, which is 11, and the adjacent leg, which is x. Notice that we don't know what the hypotenuse is in this case. Again, because across from the 90-degree angle is always the hypotenuse, and that side is unlabeled. So if we look at the tangent allows us to use the opposite and the adjacent legs. So we're going to say that the tangent of 21 degrees is equal to 11 divided by x. To simplify, we can multiply both sides by x, and notice that we will get x times the tangent of 21 degrees is equal to 11. And to solve for x, we can now divide both sides by the tangent of 21 degrees. This tells us that x is approximately, and again, let's go over here to Desmos. So we're going to say 11 divided by the tangent of 21. And that gives us approximately 28.7. All right, so that's how we can use Sohcahtoa to find missing sides. But now let's talk about finding missing angles. To find the measure of an angle using Sohcahtoa, we must use inverse sine, cosine, and tangent. So on a standard calculator, you would see them written as sine, cosine, and tangent to the negative first power, but Desmos also has inverse sine, inverse cosine, and inverse tangent as well. So let's see how we would use those inverse trigonometric functions to find the missing angle x. Let's start with this example right here. So we have relative to x, we have the opposite leg, and we have the hypotenuse. Again, 12 is the hypotenuse because it's directly across from the 90-degree angle. So we could say that, all right, the sine of x, let me use a different size here. The sine of x, because we don't know the measure of x, that's what we're trying to find, is equal to 8 over 12. Well, if I want to isolate for x, I need to get rid of sine. So we would take the inverse sine of both sides. So taking the inverse sine of both sides, so the inverse sine of the sine of x, and again, this is an equation, so we also take the inverse sine of the right side as well. And what this does, well, the inverse sine and the sine will cancel each other, and this tells us that x is equal to the inverse sine of 8 over 12. And let's use Desmos to approximate that. So we would take the inverse sine, which is right here, sine to the negative first power, or inverse sine, of 8 divided by 12. And that's going to give us about 41.8 degrees. Notice that this time we need to be careful and write that this is a degree measure because we are solving for a missing angle. So x is approximately 41.8 degrees. Now let's try the next problem. So now, relative to x, again, we have the opposite, and we have the adjacent, and this time we don't know what the hypotenuse is. So this tells me that we need to use the tangent. So the tangent of x is equal to 32 divided by 40. Just like in the previous problem, to isolate for x, we need to take the inverse trig ratio of both sides. So we'll take the inverse tangent of both sides. All right, well, on the left side, inverse tangent and tangent, they will cancel. We get x. And on the right side, we're going to use Desmos to calculate the inverse tangent of 32 over 40. All right, so inverse tangent, 32 divided by 40, and that gives us approximately 38.7 degrees. So x is approximately 38.7 degrees.